Okay, communication system, which is the one of subsystem of avionics system. So communication will be providing the information to the pilot from the station to pilot, pilot to station. We will be using VHF, that is very high frequency communication signals for transferring through many altitudes and miles. Here we will be using satellites, okay, for communication purpose. So centralized 4 satellites will be used over the Pacific Ocean, Indian Ocean, Atlantic Ocean west for higher altitudes. Okay, so this is the picture of communication. How the pilots and working people in the station are communicating to each other is represented in this diagram. Through the satellite, everything are represented. So types of communication used in the avionics system are, so we are going to communicate for altitude, speed and route by the air traffic controller to pilot before hand on VOR. Here we are going to apply the technology VOR, that is omni range, very high voltage omni range, that is 108 to 118 megahertz signal will be transmitted for communication purpose between the air traffic control as well as to the pilot. Okay, air traffic control is nothing but which will be available in the air station, that is airport. Okay, so to the pilot, pilot to the airport. So vice versa, we will be communicating. So the communication by pilot to the air traffic control is through voice, which will be given through the passed through the FM transceiver. Transceiver is nothing but transmitter and receiver in a single device. Okay, available in the single device, which will be ranging from 119 to 140 megahertz, and then you will be using intercom among the cabins. Okay, and then airband radio. This is the airband radio. So airband radio is used for communication purpose. Okay, so band of frequency will be sending message or information to the, one second, to the pilot as well as to the air traffic control, which who will be in the air station. So among the communication types, the communication will be connected between the flight deck. Flight deck is nothing but pilot, okay, who is sitting near the flight deck, to the ground. To the ground means air traffic controllers. Okay, and then again to flight deck to passenger. Okay, so flight deck communication between pilot to the ground station controllers, and then flight deck to the passenger. Okay, in the same flight. Then second one, flight deck to ground work on the airband of 118 megahertz to 136.975 megahertz. This will be received or sent through the airband receiver. Okay, then onboard communication for public address system to the passenger and the aircraft intercom to the crew. So onboard communication type will be used for addressing the publics, okay, that is passengers, and then intercom will be used for among the crews, okay, among the pilots, co-workers. Then airband radio pilot to ATC. So how the air traffic control uses the airband radio for communicating with the pilots from the air traffic control, who will be in the ground station, that is the airport. Okay. So the communication system using airband receiver for contacting ATC and pilot, and then this will be in the range of 136 megahertz to 136.975 megahertz, among 720 communication channel. Okay, this will be the frequency range, but channel will be 720. Okay, around 720 channel you will be utilizing for communication purpose. Then airband radio will be available at 14 volt to 28 volt. Okay, the range of voltage the band radios available are. This is the airband radio. It is used for communication between pilot and airport to the pilot, and passenger to the pilot. Then cockpit to cabin communication. Okay, cockpit is nothing but the place where the pilot sit. Okay, the place where the entire control of the aircraft is maintained will be called as a cockpit. Cabin is nothing but your airport cabins. Okay, who will control the aircraft from the station. Okay, so controlling means takeoff and landing of your aircraft system. Okay, entire will be communicated through the uh, signals to the cockpit as well as cabin. Okay, so the flight attendants receiving the notification from the crew for turbulence. Crew is nothing but pilot. Here it means to pilot. Okay, so here the pilot will send the message to the flight attendants. Okay, and then cabin to cockpit. Again from the station to again crew. Cockpit is nothing but pilot. Communication will be replied only through the signals. Okay, this will be based on the quality of service. Then sterile cockpit regulation. So regulation specifically prohibiting crew members' performance of non-essential duty or activities while the aircraft is involved in taxi, takeoff, landing, and all other flight operations conducted below 10,000 feet MSL. So everything is regulated automatically by sterile cockpit regulation, by sending the signal automatically without interpretation of your pilot or any controller in the ground station. It will be automatically sending the alert signal for or controlling purpose. Okay, of the flight operation, which will be below the 10,000 feet altitude. This is the airband receiver. Okay, this is radio altimeter. Altimeter is nothing but the device which is used for measuring the height of aircraft from the ground. And next we are going to see flight control system and FMS. What is FMS? Flight management system. So flight control system, it means to automatically controlling flight. So automatically controlling flight is nothing but autopilot. Autopilot will be used for controlling heading and altitude. So height of the your aircraft system, and then heading, that is position of your aircraft, will be automatically controlled by autopilots. Here you will be using two methods of flight control system. That one is fly by wire and another one is fly by light. So here we use limited authority for controlling. Okay, because maximum of thing will be done by automatic. Okay, so limited authority will be used for flight control. Then AFC parameters. So what are the AFC parameters? Automatic flight control parameters. So stabilization of the aircraft angle and flight altitude. So aircraft angle and flight altitude will be constant. Okay, stabilization means constant. It will not change the angle and altitude. Okay, it will be constant, maintain constant. And then return of the aircraft to a straight and level flight path from any altitude. So aircraft control keeps on controlling on level flight path as well as straight path from any of the altitude of aircraft system. Okay, and then programmed flight altitude, climb and descent. So it will be keeping program for flight altitude, that your aircraft system in the sky as well as while it is uh, moving from sky to the ground. Okay, that is landing. Okay, and then control from ground and air direction post, and also it will kind of have the control over the air as well as in the ground direction post. And then self guidance interface to the weapon control system.
ஆமா.
Okay, it will provide interface between the weapon control system. And then en route
போயிட்டாங்க
in
மேம்.
flight, return to home airfield and landing approach by radiant beacon.
நாளைக்கு வெண்டிலேஷன்
So
வரணும்.
landing, and then it again reaching to the home airfield, everything can be indicated or given alert signal by the radio beacon is nothing but light signal given by the
இதுக்கு மேல போனா பேங்க் இருக்க
device.
மாட்டேங்குது சொல்லுங்க. இது இந்தியன் ஓவர்சீஸ் பேங்க் வந்து 4 ரூபாய்க்கு இருக்கும். இந்தியன் பேங்க் 3 மணி நேரம் க்ளோஸ் பண்ணிடுவாங்க. 5 மணி நேரம் இந்தியன் பேங்க் காசு எடுத்தா கரண்ட் இல்லை போல, சுத்தமாக சார்ஜ் போட்டுச்சுரா. கரண்ட் பெருங்கோட்டில் போட்டாங்க தேரல. எரியுதுன்னா கேட்க சொல்லுங்க. அண்ணியா அம்மா வீட்டு போறான். அப்படியே வண்டி அண்ணன் அண்ணியோட அண்ணன் இருக்குதா வந்துருக்காங்களா? சாயங்காலம் 5 நிமிஷம் 10 நிமிஷம் தான் வீட்டில் விட்டு போயிடும்.
So autopilot system will be used in automatic flight control. So automatic flight control will always keep on tracing the aircraft level, and then it will be setting course for flight computer. Okay, here you will be using mechanical, electrical and hydraulic system to guide the uh, aircraft system without having any assistant. Okay, from the pilot, for maintaining the parameters, that is altitude, airspeed, rate of climb or descent rate. Okay, so without having the interference of or interpretation of manual control, you will be having the automatic control on the flight, on the parameters of altitude, airspeed and descent rate and climb rate. Okay, so here autopilot system will use integrated processor. Integrated processor is nothing but the processor which will be having all the accessories, okay, peripheral devices for controlling the entire system. This is flight computer system, the computer system which is used in the aircraft. Okay, so objective of flight management system, FMS. So a flight management system aim is to provide end-to-end flight planning. Okay, it will be used for planning end-to-end flight management, and then it will be controlling the aircraft track to the accuracy of 3 wing width and time of arrival to within 6 seconds anywhere in the flight plan. So it will be able to control the track of aircraft by providing the 3 wing width. Okay, So, and also it will provide timing. There is 6 second. So wherever your airplane is there, then it will be able to arrive within that time. Okay. Then navigation. So navigation will be controlled by the FMS, either radio navigation or GPS sensor, whatever it means, it will be controlled automatically. And then trajectory prediction optimization. Okay, it also used for predicting all the errors which is occurring during the uh, flight mode. Okay, and then flight guidance interface. So it will guide the all commands by giving all the commands, that is roll, pitch and thrust. Okay, then electronic map interface. So that is nothing but where it is located. The your aircraft is where located. That will be provided automatically to the pilot or controller. That is horizontal, vertical, flight plane, display. Okay. The next we are going to see radar subsystem types. So what is the radar subsystem usage? Okay. Time in a 3 dana. Okay.